Have you ever wondered how lightning forms or why it often strikes trees? Well, today we'll answer these questions and more. Let's get started. Inside a thundercloud, strong updrafts and downdrafts cause ice crystals and supercooled water droplets to collide with each other. These collisions charge the droplets and crystals by friction. Typically, the larger hailstones gain a positive charge, while the smaller droplets become negatively charged. Eventually, the charges within the cloud become so great that they begin to influence the ground below. In fact, the negative charge at the bottom of the cloud can repel electrons on the ground to such a degree that the surface of the Earth becomes positively charged. This creates a massive electric field between the cloud and the ground. If the electric field is strong enough, a negative channel of charge known as a stepped leader will form. It zigzags downward from the cloud in steps, giving it the appearance of a staircase. Now, keep in mind that the stepped leader is invisible to the naked eye. It's only about 1 centimeter wide and consists of a thin, narrow stream of negatively charged particles. If the electric field is strong enough, a thin channel of negative charge called a stepped leader zigzags downward from the cloud. This leader moves in steps, invisible to the eye. However, once it gets close enough to the ground, tall objects like trees, buildings, power poles, and even people can induce an upward-moving streamer of positive charge. This happens because the negatively charged stepped leader creates an electric field around itself. And when this field is strong enough, it can overcome the insulating properties of the air and push electrons from the ground up towards the leader. When the stepped leader and streamer meet, a powerful surge of current flows along the path. This sudden discharge of electricity is what we know as a flash of lightning. And when lightning strikes, it often strikes trees. But why do you think that is? Well, here are 3 reasons why lightning often strikes trees. First is their height. Generally speaking, the taller an object is, the more likely it is to be struck by lightning. And that's because the taller the object is, the higher it is above the ground, meaning it's closer to the clouds where most lightning occurs. Of course, there are exceptions to this rule, but it's generally true that taller objects are more likely to be struck by lightning. For example, if you were outside and your hair stood on end, it would be a good idea to bend down and crouch low to the ground because that would make you a smaller target for lightning. The second reason has to do with the moisture and sap that trees contain. That's because trees have a high moisture content. Not only do they absorb water from the soil through their roots, but they also transpire water vapor from their leaves. This water vapor adds to the humidity of the air around the tree, creating a more conducive environment for electricity to flow. Additionally, the sap that flows through the tree contains dissolved sugars, minerals, and other compounds that can carry an electrical current. Therefore, trees can act as natural conductors of electricity, making them more susceptible to lightning strikes. In contrast, dry air is a good insulator, meaning that electricity cannot flow through it easily. So trees with their high moisture content can provide a path of least resistance for lightning to follow. The third reason has to do with the pointed tips of tree branches. You see, the electric field surrounding a charged object like a lightning bolt is strongest at its sharpest points. Tall objects like trees have pointed tips that concentrate the electric field. This means that the electric field is stronger at the tip of the branch than it is elsewhere on the tree. And when the electric field is strong enough, it can overcome the insulating properties of the air and create a path for lightning to follow. So the pointed tips of tree branches can act as natural lightning rods, attracting lightning strikes. In fact, it's not uncommon for lightning to strike the same tree multiple times in a short period of time. This is because once a tree has been struck by lightning, it becomes charged and can attract more lightning strikes. Additionally, the path of least resistance created by the lightning bolt can remain in place for some time, making it more likely that the tree will be struck again. It's interesting to note that while trees are more likely to be struck by lightning, they don't always get hit directly. Sometimes the lightning bolt will strike a nearby tree or object and then jump to the tree. This is known as side flash. Side flashes can be just as damaging as direct strikes, so it's important to remember that if you're outside during a thunderstorm, you should avoid standing next to tall trees or objects. Instead, you should move to a low area away from tall trees, buildings, and power lines. Now let's take a look at some amazing slow-motion footage of a lightning strike in a forest. You can really see the bolt zigzagging through the trees. It's incredible how much damage a single lightning strike can do to a forest. The trees are literally on fire. But did you notice something else in this video? There are a lot of pine trees, which are known for being very resistant to lightning strikes. This is due to their conical shape, which helps to disperse the electrical charge and prevent it from concentrating in one area. Another type of tree that is resistant to lightning strikes is the eucalyptus tree. Eucalyptus trees have thick, fibrous bark that acts as a natural insulator, preventing the electrical current from traveling through the tree. Additionally, the oil in the leaves of eucalyptus trees has a high flash point, meaning that it's difficult to ignite. Interestingly, lightning is not the only natural phenomenon that can damage trees. High winds, for example, can uproot trees or break off large limbs, which can create openings in the canopy and allow more sunlight to reach the forest floor. This can lead to the growth of smaller trees and shrubs, which can compete with the larger trees for resources like sunlight, water, and nutrients. This competition can weaken the larger trees, making them more vulnerable to lightning strikes and other types of damage. In addition to the physical damage caused by natural phenomena, trees can also be affected by changes in the climate. For example, prolonged droughts can cause trees to become stressed and more susceptible to pests and diseases. Additionally, rising temperatures can lead to more frequent and severe heat waves, which can damage trees and other vegetation. Despite these challenges, forests have the ability to recover from disturbances like lightning strikes. After a lightning strike, the damaged branches and leaves are decomposed by fungi and bacteria, which release nutrients back into the ecosystem. These nutrients can then be used by other organisms, including the trees themselves, to grow new branches and leaves. Additionally, the gaps created by lightning strikes allow for the growth of new trees, which can help to regenerate the forest over time. But not all trees are equally susceptible to damage from lightning. Some species are more resistant than others. For example, oak trees have thick, sturdy branches that are less likely to break. Additionally, the bark of oak trees is thick and fibrous, which helps to insulate the tree and protect it from electrical damage. So while lightning can cause significant damage to forests, it's important to remember that forests are resilient ecosystems that have the ability to recover over time. Different species of trees have different levels of resistance to lightning damage, and some species are more susceptible than others. If you enjoyed this video, check out our other videos about nature. We have a ton of videos on thunderstorms, tornadoes, hurricanes, and other topics. Thank you for watching, and we'll see you in the next one.